Algebra 1, let's get started with our notes. This is chapter 0, lesson 1. This is the plan for problem solving. This is what we're going to want to do when we approach a problem and we need to figure it out. So they have a 4-step problem solving technique here, broken into 4 steps. And what it comes down to is step 1 is to understand the problem. And to understand the problem, a lot of times that means read it, yes. Read the problem, whether it's a word problem, whether it's just the directions. Does it say factor? Does it say add? Does it say subtract? Find the sum, find the product. All of those things, you need to understand what you need to do. So that's the first thing you're going to want to do. Second thing is, with that step 1, is identify what information is given. So if we're talking about traveling in a car, so if I give you a problem of, this summer I took a trip to Wisconsin Dells, and it took me 3 hours to get there, and the car was going, or we went, I don't even remember how far it is, maybe 150 miles. I'm not sure. I forgot what the distance was. What was my average speed? You know, a problem like that. Okay, identify what it's given. Okay, we're given that it took 3 hours, did I say 3 hours, to get there, and you need to identify that it was 150 miles. Then, the last thing is, what do you need to find? Well, I need to find what the speed was during that whole entire trip, that average speed, right? So you got to list those types of things. Usually, what it's asking you to find is usually at the end, right? That's at least a word problem. Step number 2. Step number 2 is plan the solution. That means, is there a formula that you can use? Is there something that you've seen before? What links my speed, or sorry, is there a speed, a distance, and time? Do we all know that? There's actually an equation. At least for our little example that I didn't write down. There's a connection between those 3 things. Does anybody know what it is? You probably have used it. You guys pretty much have used it anytime. You guys start driving, it'll make it more obvious that you're using it in your head. Distance equals what? Distance equals rate times time. Right? Distance equals rate times time. If you know any 2 of those, you can find the third one. Basically, a little example that we don't have written down right now, that's something you would use. Where D would stand for the distance, R is for the rate, aka speed, and T stands for time. You list those, and then you can write your expression. Oh look, there's my expression. Oops. There's the expression. We would probably want to write D equals the distance, R equals the rate, T equals the time. Okay? That's kind of defining your variables. D is the distance, and R is the rate, and T is time. Then it says write the expression. Sometimes the order doesn't matter which one you do first, because sometimes the formulas come to us. And then we can say, okay, that's right, D was the distance, and so forth. Step 3, solve the problem. It means put the stuff you're given in. How far did we go in my problem? What was that distance? 150? Did we know the rate? Did I tell you how fast I went? Nope. Did I tell you how long? 3 hours. So now can we solve? How do I solve for R? Divide both sides by 3. What's 150 divided by 3? So 50. So in step 3 it says solve the problem, use the strategy you chose in step 2, the equation. Okay? Step 4 says check your solution. Does 50 times 3 equal 150? Yeah. Does it make sense? What is 50? Wait, what does 50 even mean? Does it fit the information? 50. Hey guys, I went 50. You went 50 what? How far? What's the label on this thing? Yeah, front. Miles per hour, right. It's miles per hour. Notice that it didn't have labels, but it's the distance, miles, divided by time, which was in hours, so it's miles per hour. The question is, does it make sense? Because a lot of times we talk, sometimes our math problems are a little bit contrived. No one goes to the store and buys 50 watermelons, okay? But, I think we've all seen the picture of the cart full of watermelons. That's the guy that everybody talks about in math problems. But does 50 miles per hour seem logical for driving in a car? I think so. If I said that I was riding my bicycle and I averaged 50 miles an hour, you guys are doing what? You guys are saying, no, that's pumping your legs pretty darn fast. So, does it make sense? Does it fit the information that we're given in our problem? Okay, are there any questions to that? So our first problem is Ling's hallway is 10 feet long and 4 feet wide. He paid $200 for someone to tile his floor. How much did Ling pay per square foot for the tile? Okay, so we got to understand the problem. I'm assuming it's either $200 for him to buy the tile itself, or it's $200 for the labor. Doesn't really specify, but doesn't matter. Not really. But what are some important numbers here? What are some important things?
The dimensions.
The dimensions of the hallway. We have a length and we have a width. The length is what? 10 feet. The width is 4 feet. Okay. What other information do we have? What other number stands out? Or something that stands out? Yeah?
It costs $200.
$200. I'm just going to circle that. That's $200. What's the link between the length and width and $200? How should I say? What's it asking? What's this asking us to find? It's not asking us for the square feet of this hallway. It's asking us what?
How much he paid for the square foot?
How much he paid for the square foot. So how much did he pay per square foot? Now here's the thing. It gives you, in that sentence, what you need to do. Pay per square foot. Think of it that way. Think of it as pay per foot squared, right? Per means what when we're talking in math? What would per mean? Or what would per do for us? Someone said something over there. For every one, okay. Trying to think of a better way of using per. Pay per view, I guess. Why do we say that? You paying for every time you view, or it's the cost. It would be the cost divided by the times you view it. I guess that one actually wasn't too good. But per in this case for math means divide, right? You're paying per square foot. Pay divided by square foot will tell you the amount of money per square foot then. So that's kind of what understanding the problem. We got some stuff laid out, and it's asking us to find this. We need to find how much does it cost. We know that. That's $200. Over square feet. How many square feet do we have? Do we know it yet? Did it just tell us? It didn't tell us the square feet. It told us dimensions. How do you find square feet? AKA, find the area. So, wait a minute. We don't have area listed. So, that means we've got to go area. What's the formula for that? Area equals length times width. I think we talked about length and width right here. So, to go back here, I can say L equals the length, W equals the width, which equals 10 and 4. Yeah? So, that means area is equal to 10 times 4, which is 40 feet squared, right? Because feet times feet is feet squared. Now, I can take that value and place it where a feet squared is. Bless you. Notice that my labels don't cancel. I got money on top, feet squared on the bottom. So labels aren't going to cancel, but my numbers, 200 and 40 down below, can be reduced. What's 200 divided by 40, Richard? So it's 5, and it's dollars per square foot. So he paid $5 per square foot. That's $5 for a tile, basically. This tile usually comes in about a square foot. Some are bigger, some are smaller. That's probably some nice tile. I don't know if anybody's ever gone in a not departments, or like a home store and looked at tile with their parents. Does that make sense? Sure. This example is Emily's family drove. Oh, that's our problem we kind of just did. Drove 254.6 miles. Their car used 19 gallons of gas. Describe the car's gas mileage. What do we need to understand about this one? Instead of rewriting it, we know they go how far? 254.6. We also know they use some gas, and how much of that do we use? Whoops. 19 gallons. So that's something that we have to understand. We also need to understand what it's asking us to find, and that is the gas mileage. But some of you guys don't drive cars. Well, actually, I don't think any of you drive cars yet. But this will become a factor for you, because the better your gas mileage your car, the less you put in for gas, and the more money you get to spend on bubble gum. So, how do I find gas mileage? Richard?
You divide.
Divide what? Okay, we're going to get there. But overall, before we put numbers into it, we need to make that plan. What is that equation? So, gas mileage is equal to what? You are dividing. I would agree. Divide. Divide what?
250.
No, we're not going to fill in yet. That's what Richard said. Before you fill in, what are you putting in there?
Units.
What units?
Miles and
Miles
gallons.
and gallons. Or your distance, right? The total distance the car drove, and divide that by the gallons of gas you use, you'll get your mileage, your gas mileage, your fuel mileage, right? Most cars do this for you nowadays. Back in the day, you had to do this yourself. Some people had a hard time figuring that out. You just take the distance you traveled since the last time you filled up, divide by how many gallons it took to fill the tank back up, and you got your gas mileage. Gas mileage we can call G if you want. D for distance and, G for gallons. Gas mileage, we'll leave as gas mileage. So we can just go, this is D divided by G. And a couple of you guys had already spoken and said that our gas mileage is equal to the 254.6 miles to what? 19 gallons. Our label on our gas mileage will happen to be what? What's the label going to be? Miles per gallon. So miles per gallon is the label. Take your calculator out. What is it? Yes. 13.4 miles per gallon. Does anybody know what their parents get for fuel mileage? Gas mileage? Is that acceptable? That's kind of low. You're probably driving a truck or pulling a trailer. Okay. I did drive a car. My first car was a 77 Ford Granada. I think I got somewhere around 10. But that was back in the 70s. And you wonder why they had a gas shortage. So, nowadays, you're probably looking at, what, mid-20s for most vehicles? So, you got to put that in perspective. Today's, that's not a good gas mileage. I would hope nobody would buy a car because of that gas mileage if they saw that on the lot. Okay, does that make sense? So the homework is on page P6, and it's 1 through 6. Have a great day.